So we'll be talking about the atom. Let me kind of put this to full page here. Now, we're going to talk about the atom, the parts of the atom, and then take a look at how scientists use the parts of the atom in starting to develop the periodic table and the different parts of it, and how we can use the different parts of the periodic table to get pieces of information. Now, with the atom, I'm going to start with this. I'm going to start with something like this. And I'm going to call this the nucleus. And I spelled it wrong already. Awesome. All right, the nucleus. What is in the nucleus of an atom? Protons and neutrons. So I'll put a P with a plus there because that's a symbol, or the symbol for proton. And for neutron, it's an N. So I'll say that's a proton. We'll talk a little bit more about that. That's a neutron. And there's quite a bit of them. There could be quite a bit of them. Sometimes there's a lot, sometimes there's only one. But they are going to be located inside the nucleus all the time. Now, I'm just kind of drawing this. And it's kind of like an area around the nucleus. Now, what do we call that? The electron cloud. So that's your electron cloud. So you might have an electron hanging outside in the cloud like this. Now, this is not the best representation of what actually is going on, because based on energy levels of electrons and things of that nature, there's a certain geometry or a certain shape of where these electrons are going. We're not going to get too much into that yet, but the electrons are going to be kind of outside the nucleus. They're never going to be inside the nucleus. And the nucleus of the atom is always going to have your protons, and it's always going to have your neutrons. Now, a couple things that you want to know. We're going to make a little chart here. So you can have this information. Proton, neutron, electron. Okay, so we're starting with that. Now, the first thing is the symbol, which we've already done. Proton is a P with a plus. What's the neutron? It's an N. Electron, E with a minus sign above that. And that's going to indicate the charge. Electrons are charged. Are they charged positively or are they charged negatively? Negatively. Nice job. What about protons? Positive. I always think protons are a P, so it's positive. Electrons are an E, which kind of sounds like electricity, and usually you don't want to get hit by electricity, so they're negative. Neutrons are neutral, which means they have, what charge do they have? 0. And sometimes with the symbol, there's actually a 0 with the N. So if we talk about charge, and we talk about relative charge, the proton gets a 1 plus. What does the neutron get? 0. What does the electron get? 1 minus. So that's just a naming convention on the part of the books here. Now, let's talk about location. With respect to the nucleus, is the proton inside or outside the nucleus? All right, so it's in the nucleus. What about the neutron? In the nucleus. The electron, is that in or out of the nucleus? It's out of the nucleus. All right, now, when we talk about relative mass, and we're keeping this stuff straightforward, relative mass is not necessarily the actual mass of these particles, the proton, the neutron, and the electron. But what you're doing is you're comparing them. And here's a way that you can kind of think of it. Say you have someone that weighs 100 pounds, 100 pounds, and 200 pounds. That 100-pound person, you give them a score of 1. The second 100-pound person, what do you think their score is going to be? 1. Why would it be 1? It's equal to the mass of the first person. The mass of the first person was 100. Well, excuse me. The weight of the first person was 100 pounds, not mass. But the weight of the second person was 100 pounds. So they got a 1 and a 1. Now, what do you think the relative weight of the third person who weighs 200 pounds would be? 2. Because it's 2 times as much as the first one. Now, when we start talking about, let me move that up just a little bit. When we start talking about relative mass, we're comparing the masses of these 3 things. So, believe it or not, the proton and the neutron both get 1s. So what does that tell me about the neutron and the proton? Yep. So the proton mass is equal to the neutron mass. Now, the electron is going to get 11840. It is 1/1840th the mass of everything else. Which weighs the most? The protons and the neutrons. And this is, if you cut up a proton into 1,840 pieces, an electron would be one of those pieces. And you'd have 1,839 of them left over. So an electron is a lot smaller. But in and of themselves, they're all small. The actual mass in grams, this is 1.673 times 10 to the negative 24 grams. Now, that negative 24, when we're doing this, and we're in scientific notation, what does that mean? Does that mean it's a big number or a small number? Small. Actually, it's going to end up being 0.1 or 0.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 super duper tiny. And since the neutron has the same mass, 1.673 times 10 to the negative 24 grams, that is super, super tiny. Now, the electron is 9.11 times 10 to the negative 28 grams. So that's where since it's still a lot smaller than these at a huge factor. So it doesn't weigh much, or its mass is not much of anything. So that's pretty much the structure of the atom. And what you need to know is, for this part of it, alright, the atom is made up of a nucleus. Protons and neutrons live in the nucleus. Outside in the electron cloud, the electrons are going to be moving around. And I'll give you one hint. Electrons and protons, they're like twins. If there's a proton, there's an electron. Especially, well, when the element is stable and isn't positively or negatively charged, when it doesn't lose an electron or gain an electron, which can happen, the protons and the electrons are going to stay the same. This information is going to be helpful, especially this stuff, when we start calculating atomic mass. But for right now, this is what you need to know. Everybody okay with this? Cool. All right.